Geometry Lesson 76, we're talking about symmetry. Symmetry is a property illustrated when the image of a transformation of a figure coincides with the pre-image. There are several different kinds of symmetry that we're going to talk about. Really, we're going to talk about two properties of symmetry today. We're going to talk about line symmetry and rotational symmetry. Okay? Line symmetry. Line symmetry is if a figure can be reflected across the line so that the image coincides with the pre-image. The line that divides the figure into two congruent reflected halves is a line of symmetry. Essentially, what you want to ask yourself is, can I fold this across this line and it match perfectly back onto itself, right? So that there's no overhang or overlap, right? So we have in our picture of this arrow, we have one line of symmetry that we can draw. Now, different figures will have multiple lines of symmetry, okay? Especially regular polygons will have multiple lines of symmetry because when we start talking about those, we can draw from opposite vertex to opposite vertex or from opposite side to opposite side, okay? So the figure at the right has a vertical line of symmetry. Are there any other lines of symmetry that I can draw with that figure? Just a simple yes or no. No, right? I can't create a line, let's say here, fold it across that line and it match up, right? Right, it won't work. All right, so that's an example of line symmetry. Okay? Then we have what is referred to as rotational symmetry. And rotational symmetry is a type of symmetry which describes a figure that can be rotated about a point by an angle less than 360 degrees so that the image coincides with the image. Basically, we're talking about picking a point, spinning it on that point, and it mapping back onto itself less than 360 degrees. Because the reason we say less than 360 degrees is because anything will map back onto itself if I spin it all the way around. Does that make sense? All right. The smallest angle through which a figure can be rotated in order to coincide with itself is called the angle of rotational symmetry. You might be able to rotate something multiple times and it map onto itself. Okay, this figure has 180 degrees of rotational symmetry, and I'll try to illustrate that here if I can. All right, so we see it like this, and if I take it to 180 degrees, I'm back to that same shape that it had, right? So that's 180 degrees. Again, if I go 360 degrees, I'm back to where I started. So it really only has rotational symmetry every 180 degrees. Does that make sense? Great. Okay. Here's a regular hexagon. Not only does it have line symmetry, but it has rotational symmetry. It's symmetrical across a vertical line, a horizontal line, and any line drawn through opposite vertices. So it has 60 degrees of angle symmetry. So we're seeing this line here. We're seeing that goes from side to side. We're seeing this line here that goes from vertex to vertex. So there's two lines of symmetry. We would also have this line. Okay, so we're up to 3, 4, 5, 6. So that's what we should find out about regular polygons, is that they're going to have the same number of lines of symmetry as they have sides. Okay? Does that make sense? So a hexagon is going to have, a regular hexagon will have 6 lines of symmetry. Okay? A regular triangle should have 3 lines of symmetry. A square should have 4 lines of symmetry, and so on. Okay? Pentagon 5, so on and so forth. Okay? So let me erase some of this. Okay, the other thing I want you to see is the rotational symmetry that it has. And I don't know if, yeah, I can do this. All right, so, okay, 1, 2, 3, 4, 5, 6. All right, so in order for me to find the number of degrees, I would take 360 and divide that by 6, and that's how I'm going to get 60 degrees of angle rotational symmetry. Does that make sense? So I'm mapping back onto itself. I can rotate it 6 times. Okay, each time it's going 60 degrees. Okay. Then we have order of rotational symmetry, and that's the number of times. The hexagon had an order of rotational symmetry of 6, and it's coincided with itself 360 degrees. A square has an order of 4. Okay, it will map onto itself 4 times. It's going to have rotational symmetry of 90 degrees. Okay, because we're going to take 360 and divide it by 4. We should get 90 there. Okay. Any questions about any of this? So far, does this make sense? We can understand that visually. Okay, I believe that's our last slide here. So what I'm going to do is I'm going to switch over to this, and we're going to see if we can answer some questions. Again, this should all go relatively quickly. We want to decide whether this figure has line symmetry. If it does, we want to pick the one that has all of the lines of symmetry. Again, it has to map onto itself. And you'll notice that this is a rectangle, okay? So let's see, just on this figure alone, can anybody come up here and draw a line of symmetry for me? Okay, all right, Austin's going to draw me at least one line. Nope, did it not? It'll probably show up here in like an hour. Whatever. Okay, he is right. The line that he drew, and there it is. The line that he drew would work. Does anybody want to come up here and draw another line of symmetry? Okay, Caleb? All right, I'm going to set you up with a different color. Okay, very good. Yes, we can fold it hot dog, we can fold it hamburger. Right? Are there any other lines of symmetry that we can draw here? Yeah. Sure. All right, I'll give you a different color. Okay, and that's a common thought, all right? But I'm going to explain why that doesn't work, okay? Because it has to map onto itself, right? We get kind of used to, a rectangle is not a regular quadrilateral. So if I try to make a diagonal line and fold this paper across itself, what I'm going to notice is that it is not going to fit onto itself perfectly, if I can even fold that line. Okay? Okay, it's not great, but you'll get the gist of this. Nope, not at all. My goodness, I can't fold paper today. Whatever. All right. So this is typically, it's not perfect, but this is what you're going to see happen when you try to fold a rectangle diagonally, that it's going to end up, I guess for the sake of being able to draw it for people that can see it, if I take this, what I'm going to wind up with is something that's going to look like that whenever I try to fold that rectangle over. So our green lines that we see up here, do we understand now why those won't work? Okay. It's B, right? It's simply B. Okay, but I'm glad that you did that because it gave me an opportunity to explain why that doesn't work out for us. All right, let's come down here and do another one. We want to decide whether the figure has line symmetry. If it does, we want to draw all the lines of symmetry. Okay, does this look like pretty much like a regular figure? Like it's essentially kind of like a square, correct? All right, so would A work, right? Can I, if I just looked at, let's draw this across, could I fold that across and it would map, right? And that means I could probably do this other one, right? So that works. C says no lines of symmetry, so we can, throw that out. All right, but look at D. Could I do down the middle? Would it fold over? Okay, and this way, would it fold over that way? Okay, so we'd end up with B as an answer there as well, correct? I know this doesn't seem very mathematical at this point, right? We're looking at pictures, and could I fold that, right? Feels like a game show. Can that fold? Yes, it can. Okay. So again, this was originally supposed to be a double lesson day, but I thought, you know what? It's our first day back. Let's kind of take it easy. Now, this includes two different shapes, right? We want to find all the lines of symmetry of this flag, but keep in mind that we are working with a rectangle, right? So will A work? Yeah, A will work. Okay. What about C? No, because I can't do diagonals with a rectangle. Okay. We know if A works, then B is not true. What about D? Yeah, we can fold hamburger, hot dog on a rectangle, and of course the circle has got an infinite number of lines of symmetry. Right, just so long as I'm cutting through the center of the circle. So D is our answer there. Okay. Oh, get this guy. All right. Now, this switches gears. This talks about rotational symmetry. We want to tell whether it has rotational symmetry. If it does, we want to give the angle of rotational symmetry and the order. Okay? So, if I pick this center point here, can I rotate it so that, let's say, we've got that point, right? Whenever I rotate it, let's say clockwise, going this way, will it map onto this point right here, right? In which case, this point will move up to where the blue point is. The blue point will move to where the red point is, right? But it will still be in the same shape, right? It'll map perfectly onto itself. How many times can I do that before the blue point gets back to where the blue point was? Okay, I can move it once, twice. Okay, so it's going from red to white, from white to green. Okay, green back to blue. So 1, 2, 3, 4. Okay, let me make sure that that's right and it's not just 3. Yep, has an order of 4. Now, just like with a square, if I can rotate it 4 times, right, how am I going to find the angle of rotational symmetry? Okay, what's 360 divided by 4? All right, so the angle of rotation is 90 degrees. It does have rotational symmetry, so, and because the order is 4, I'm getting B as an answer there. Okay, so far so easy? Great. All right, number 5 is kind of like one of the last ones we looked at, except they're going to complicate things a little bit more. Okay, we want to describe the symmetry of the quilt patch. We want to draw all the lines of symmetry. If there's rotational symmetry, we want to give the angle and the order. So they're asking for a lot of stuff here. Okay, the biggest thing to remember is on the outside it's a square. The next one inside is a square. The next one inside is a rectangle, right? That causes us obviously some problems. And the very one on the very inside is just a dot. Okay, so how many lines of symmetry can I draw? 2, because of the rectangle, correct? So if I look down here, right, I ought to be able to tell right off the bat that there's only 2 of these that work, correct? Which ones? A and B, right? I only have 2 lines of symmetry. I can't do C or D. All right, so we're going to have 2 lines of symmetry. If there is rotational symmetry, we want to give the angle and the order. Okay? So with a rectangle, how many times can I rotate it back onto itself?
Sorry, I can't search the web on Apple Watch.
Okay, I didn't ask you to. Think about this here. Let's just take just the. Hold on. Let me. I don't know if I can do this or not. Let's kind of come back to this guy over here. Let's make a rectangle. Let's take this guy. Okay, there's a rectangle. Let's see. If I take this, all right, we want to find out how many degrees it will rotate back onto itself. Okay, you guys said 4, right? All right, so that's 1, correct? So it's back onto itself? No. What about there? All right, how many degrees was that? 180 degrees. So a rotational symmetry of a rectangle is 180 degrees. All right, has symmetry order of 2. It's going to map onto itself once, twice. Okay, does that help you out a little bit? Okay, I hope so. All right, so if we look down through here, all right, if we're picking between A and B, does it have rotational symmetry of 180 or 90? 180. And what was the order? 2. Okay, so we would go with answer A there. Okay, I kind of like the fact that I can go and I can actually rotate some stuff for you so you can see how it works and how it maps. Okay, and let's come down here and look at another question. What is the angle of rotational symmetry of an equilateral triangle? Okay, so let's go and let's get an equilateral triangle. Okay, we can get rid of our triangle there. Let's see. We need shape. Let's do this guy right here. Equilateral triangle. Does that look like an equilateral triangle? Okay. What is the angle of rotational symmetry of an equilateral triangle? Okay. So tell me when to stop. Can I stop there or keep going? Stop. So that's how many? Okay, that's 1. How about there? It's like 2, 3. Okay? So how would I find the rotational symmetry there? How many times does it map onto itself? 3 in 360 degrees. Erica, you said what? What's 360 divided by 3? 120 degrees. And the other thing I consider without drawing the picture is that an equilateral triangle is a regular triangle. So all I had to do was take 360 degrees divided by the 3 sides of a triangle. Okay, and that's going to give me 120 degrees. Okay, so we see that up there. Number 7, a student repeatedly rotates the equilateral triangle 60 degrees about point M. So not at necessarily at the center, until it coincides with itself. What is the order of symmetry in the final figure? This question doesn't make sense to me, so we're going to skip it. Okay, we're going to skip number 7. To this day, I still don't understand how they get the answer that they get, so we're not going to mess with this one. Let's look at question number 8. Okay, which we still have a few more. How many lines of symmetry does a regular hexagon have? We've already answered this question, right? How many? 6, right? Because I can draw 3 lines that are going to take me from vertex to vertex diagonally and from side to side. And because it's regular, right, we count the number of sides. So 6. We've already answered this question, I believe, right? Does it have rotational symmetry? Yes. Okay, what's the angle of rotational symmetry? We just answered this a little bit ago. 120 degrees has an order of 3, correct? All right. Number 10, does the shape below have any lines of symmetry? If so, how many? Okay. How many lines of symmetry do we think we can draw here? 1. Jesus, you want to draw that line of symmetry for me? Perfect. That is the one line of symmetry we can draw with that. All right, guys. That is the end of our notes and our practice here. You guys should be able to get started with this lesson. It's 9:25 right now. You guys have until what, 9:48? So you guys have 23 minutes to work on this assignment. That is unprecedented, right? So get to work, use the time wisely.